Welcome back, students. So, last video we discussed about distance time graph. Here, next is velocity time graph. Means we need to represent the velocity of an object according to the time on a graph. That is velocity time graph. So, first one is velocity time graph when the object is moving with constant velocity. When the object is moving with constant velocity. In the same way, you need to draw the x-axis, y-axis. You have to mark time along x-axis and velocity along y-axis. And when you plot the graph, the shape of the graph will be like this. It's a straight line parallel to the time axis. It's a straight line parallel to the time axis. This one I will draw it. So, second type, first one, velocity time graph. There is a heading. So, in that first one, object moving with constant velocity. Object moving with constant velocity. So, when you plot a graph, this one is x-axis, y-axis, origin, time along x-axis, velocity along y-axis and its SI unit in brackets. When you plot the graph, you will get a straight line like this. That means it's parallel to time axis. The graph is a straight line that is parallel to time axis. Now, we can find two things from this graph. First one is the acceleration and second one is a displacement. We can find two physical quantities from velocity time graph. First one is the acceleration and second one is the displacement. Actually, we will find the magnitude of displacement. Okay, we will find the magnitude of displacement. Now, we will find the velocity. From this graph, we will find the acceleration. You know, what's the equation to find acceleration? Acceleration equal to change in velocity by time. Change in velocity by time. So, if I consider an object, time is given here in seconds, velocity in meter per second, values of time five. When you plot the graph, we will get a graph like this. It's x-axis, y-axis, velocity meter per second, time seconds, here 0, then 1, 2, 3, here also 1, 2, 3, 4, 5. So, first second means when time is equal to 1, the velocity is 5. You can mark the point here. When time is equal to 2 seconds, the velocity is 5. So, we will mark the point here. When time is equal to 3 seconds, the velocity is equal to 5. Then we will mark the point here. So, now we need to join all these points. So, you will get a graph like this. You will get a graph like this. That graph is a straight line parallel to the time axis. Now, from that graph, we can find the acceleration. So, acceleration equal to change in velocity by time. Now, is there any change in velocity? Suppose you consider from 2 to 3. Just consider from time 2 to 3. Is there any change in velocity? So, we need to consider only this portion. The equation is A equal to V minus U by T. A equal to V minus U by T. So, initial velocity is this one. Final velocity is this one. So, 5 minus 5 by 3 minus 2. So, 5 minus 5, 0. 3 minus 2, 1. That is equal to 0 meter per second square. So, the acceleration will be 0. If an object is moving with constant velocity, acceleration will be 0. Acceleration of the moving object will be 0 if it is moving with constant velocity. That is the first one. Second one, we can find the magnitude of displacement. Magnitude of displacement. Magnitude of displacement means that is equal to distance itself. Magnitude of displacement means distance itself. Distance plus direction is known as displacement. So, magnitude of displacement means distance itself. So, when you plot the graph, you got a line like this, a straight line parallel to the time axis. So, what is the area enclosed by this graph? What is the area enclosed by this graph? That will be equal to the magnitude of displacement. Now, I will consider only this portion. Only this portion I am considering. We need to find the area of only this one. From 0 to 3 seconds, what is the area or what is the magnitude of displacement? If the object is travelling with constant velocity, what is the displacement when it covers this much? When it covers a distance or distance in this much time, that is from 0 to 3. Okay. So, what's the area, what's the shape? That represents the magnitude of the displacement. So, magnitude of the displacement equal to distance, that is equal to area under velocity time graph. Area under velocity time graph. What's the shape of the graph? What's the area under that graph? Okay, area between the time axis and the graph. That represents the displacement. If it is a triangle, half BH. If it is a rectangle, L into B. If it is a square, side into side. If it is a trapezium, two methods are there. First one, direct way you can find the area of the trapezium, or you can divide the trapezium into a rectangle and a triangle and you can find the area. Now, what's the shape, what's the shape here? This one is a rectangle. So, this much is the length, that is equal to 2. Then this much is the breadth, that is equal to 5. So, this much is 2 seconds. This much is 5 meter per second. Now you need to multiply it. That is equal to area of rectangle equal to L into B, that is equal to 2 second into 5 meter per second. 2 second into 5 meter per second. This second and this second will get cancelled and you will get the area as 10 meter. Now, you will get a confusion that area unit is meter square. Don't write it like that. Here area that is equal to distance. This area equal to distance. So, we will write the SI unit of distance in after calculating the area, that is meter. Okay. You will have a confusion that area SI unit is meter square, meter into meter. But here area means that is equal to distance travel. So, after calculating the area, we will write the SI unit of distance, that is meter. So, first graph, velocity time graph, when the object is moving with constant velocity. The graph is a straight line parallel to the time axis. Two physical quantities, we can represent it or we can derive it from that graph. First one is the acceleration and second one is the displacement or magnitude of displacement, that is distance. So, to find the acceleration, we will find the slope of the graph. Okay, we will find the slope of the graph or you will take the change in the velocity by time. To find the magnitude of displacement, we will find the area enclosed by the graph. Depending upon the shape of the area, we will use the equation and find the area. Okay. So, next one, that is about this graph. Next graph is the object moving with constant acceleration or uniform acceleration. Initially, the object is at rest. When the object is initially at rest means the graph will start from the origin. The graph will start from the origin. So, here along x-axis time is represented, along y-axis velocity is represented, then the shape of the graph is a straight line. Now, this area, what is the area enclosed by this? What's the area enclosed by this? What's the shape? That's a right angle triangle. If you draw a line like this, then it will be a right angle triangle. Then the equation to find the area is half BH. The equation to find the area is half BH. So, second one, velocity time graph. This one is the origin. The shape of the graph will be like this. If you draw a line towards the x-axis, then this shape, that's equal to a right angle triangle and this area will be equal to half BH, that is equal to magnitude of displacement or distance travelled. Magnitude of displacement or distance travelled, half BH. Now, how will you find the area slope of this graph? Here you need to consider 2 points. Draw the x coordinate, y coordinate. So this one is x1, this one is x2, this one is y1, this one is y2. Now, slope of the graph, how will you find it? What's the equation to find slope of the graph? Slope of the graph equal to y2 minus y1 by x2 minus x1. Now, along y-axis, this much is y2 minus y1. This much is y2 minus y1. That is velocity. This much is x2 minus x1. That is time. That is time. So, when you find the slope of the graph using the equation y2 minus y1 by x2 minus x1, you will get change in velocity by time. Change in velocity by time. What is change in velocity by time? Yeah, that is acceleration. Okay, that is acceleration. So, two things we can find out, or two physical quantities you can find out from the velocity time graph. First one is a acceleration. Acceleration you can find out by taking the slope of velocity time graph, and magnitude of displacement you can find it from the area enclosed by the graph. Okay. Then there is a second graph. Third one, this one I will just draw the graph only. I will not explain how to find the area and acceleration from this graph. Yeah, uniformly accelerated motion. But the object is not initially at rest. So, when you plot a graph, you will get a shape like this. This one is the x-axis. Time is represented along x-axis. This one is a y-axis. Velocity is represented along y-axis. This one is our origin. Here, object is not initially at rest, means the graph is not starting from the origin. The graph is not starting from the origin. So, the shape of the graph will be like this. Shape of the graph will be like this. From this graph, we will derive 3 equations of motion that we will do in the next video. Okay. So, from this graph, this shape, we will derive 3 equations of motion, and with that 3 equations of motion, we need to derive problems. Okay. We need to solve the questions. Okay. So, this one is uniform accelerated motion, but the object is not initially at rest. Means the graph is not starting from the origin. Then one more is there, that is uniformly retarded motion. That is the fourth one. Velocity time graph for uniform retardation or negative acceleration. Retardation means the acceleration will decrease. So when you plot the graph, this one is a x, y, shape of the graph will be like this. Shape of the graph will be like this. That is uniformly retarded motion. Means the velocity is decreasing. In the rest two cases, we saw the graph is increasing in the upward direction. Means the acceleration is positive. Here it is moving downwards. That is retarded motion. Okay. So, velocity time graph, 4 graphs are there. First one, when the object is moving with constant velocity. Second one, uniformly accelerated motion, but the object starts from rest. The object is initially at rest. Second one, third one, uniformly accelerated motion, but the object is not initially at rest. And fourth one, for uniform retardation. From the third graph, we will derive the equations of motion. Okay. Thank you.